So, we saw the movie, we listened to the lecture, we learned about the book in the right order. Because, at least from my point of view, the movie is just a wonderful, wonderful teaser for the book and the lecture. And we learned here from Kip himself that to really understand the movie, you have to read the book, which was prepared confidentially and published almost secretly. And I can assure you, I saw the movies, I read the book. After you read the book, the movie is, well, you can skip it. And then I was asked by our host to lead this question and answer section, and I was asked to ask Kip some questions myself and then to give the audience chance. So I prepared some questions, and my only worry was that what amount of the answers will be covered by the lecture? Well, the first third of the lecture was just answers to my prepared questions. Well, but there are tiny bits which are still there, so I'll try to ask about these bits. I tried to focus on a tiny part of the movie, which is very, very rich from the point of view of physics, and that's the Miller planet, the water planet which you started. The first question or ask for comment is that Christopher Nolan needed this planet for this enormous time loss. As you showed us, you cannot reach it or even come close to it with a Schwarzschild black hole. You have to have Kerr black hole, rotating black hole, rotating almost very, 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 very close to the maximum possible rotation, maximum possible spin. And the Gargantua had this spin, which is quite improbable, which is not good for the story to have very improbable things within. However, as I learned from your book, The Science of Interstellar, you personally showed in a scientific paper before that you cannot get very, 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 very close, but only very close, which is 1.98 of the maximum and no 9.99999. So the movie is scientifically correct, but with a grain of salt. Is it right?
With a grain of salt, in the sense that, so this is one of my very early technical papers that I wrote in about 1973, I think. And so if you have a black hole surrounded by this kind of a disk, a thin accretion disk, as the disk, as the gas flows into the black hole, it speeds up the spin. And if that was the whole story, you could fairly quickly go all the way to the maximum spin. But in fact, the black hole then acquires, as it's spinning very rapidly, it has a cross-section, an ability for capturing radiation that spins it down, that gets much bigger than radiation that spins it up. So the gas itself continues to spin it up, but the radiation, the light coming off the black hole, it gets captured by the black hole, some of it, in such a way that it slows the spin down. So if if an advanced civilization wants to build this kind of a black hole spinning this fast, they're going to have to prevent the radiation from falling onto the black hole. And I mean, that's implausible, very implausible. And so from that point of view, I had already in 1973, I think, had proved that in the real universe with radiation from the disk falling into the black hole, this won't happen.
Yeah. Okay, so the Gargantua, in fact, is impossible.
It's impossible unless some advanced civilization prevents the radiation from falling out.
Okay. Then the next question, which was already answered, but I want to put a stress on it, that such amount of rotation of a black hole would deform the image to an extent which Christopher Nolan did not like.
Yes.
So, in spite of correctness from the scientific point of view, what we saw is not the black hole spinning as fast as Gargantua should, but only, if I remember it correctly, 60%.
60% of the maximum. That's
okay,
right.
So Nolan's insisting on this extreme time loss causes problems which he avoided just by using.
Yes. So there were compromises made. As I said, Nolan's goal was to make a great movie, but his goal was also to do so in a manner that an audience that knows nothing about these technical details will still find, will not be disturbed, will not be deeply puzzled by what they see. And he has some sense, some very good sense, I think, of what's acceptable for a general audience and what's not. It is remarkable how much he allowed in terms of wild things that were based on real science and went along with. But these were issues that we discussed at length, and we agreed on these things. The only thing that was really seriously different from how it would really appear was that trip through the wormhole. These other things are more mild, at least in my view, than the trip through the wormhole.
I think that's the reason why the wormhole is opened near the Saturn, so that the audience see the Saturn with a ring, and then the ring around the black hole is somehow similar, so they are used to it, but they are used to circle shadow of the circle Saturn, and they would expect circle shadow of the black hole, so that's what, Then there is another question. I heard an interview with Jonah Nolan, the brother and the screenwriter, where he said that yes, the ring around the black hole, we see the half of the ring, and then we see it above and under the black hole. And he said, if I remember it correctly, this is because the ring is deformed by the gravity, which sounds like if he thought that it's the ring which is deformed, as we saw in the lecture. It's just the image, because we see the ring is just as a Saturn rings, but the backside we see from the up and from the down as Now, maybe it was just misunderstanding, but maybe Jonah really thinks that the ring is deformated. So the question is, how deep do the Hollywood people really understand you?
Well, I think by the time I finished with him, Jonah understood things fairly deeply. Okay. And I think in this case, it was a slip of the tongue. The image is deformed. But he didn't understand things nearly as deeply as his brother Christopher Nolan.